Question 4, we're asked to prove that cos 2a is equal to cos squared a minus sine squared a. So let's manipulate the right hand side and get it equal to cos 2a. We know that cos squared a plus sine squared a is equal to 1. So what would that leave cos squared being? 1 minus sine squared a would be equal to cos squared a. So if we replace cos squared a with 1 minus sine squared a, we have the other minus sine squared a. We have 1 minus 2 sine squared a. Now, we have a formula in the formula booklet for sine squared a. It is sine squared a is equal to 1 minus cos 2a. So we can now say, we could say that 2 sine squared a, which we have up here, if we multiply both sides by 2, is going to be 1 minus cos 2a. So replacing 2 sine squared a, be careful with the sign, 2 sine squared a is equal to 1 minus cos 2a. And if we multiply it out, we're going to get 1 minus 1 plus cos 2a, which is equal to cos 2a. So the left hand side is equal to the right hand side. QED. Nice easy trig identity. In part 2, we're told that the sine of theta over 2 is equal to 1 over root 5, and theta is between 0 and 180, or 0 and pi, and use the formula cos 2a is equal to cos squared a minus sine squared a to find the value of cos theta. Well, let's say that the cos 2a, why don't we let 2a equal theta? Because then we can say a is equal to theta over 2, which is the angle that we're given here. So if we imagine just that the angle A is theta over 2, we can create a right angle triangle. Sine is opposite over hypotenuse, which would leave this one as 4. No, that would leave that one as 2. So we have the sine of A. We have sine A is sine theta over 2, which is 1 over root 5. And cos A is equal to 2 over root 5. So cos of 2a, so now we have cos 2a is equal to cos squared a, which is going to be 4 over 5, minus sine squared a, which is going to be 1 over 5. So you can say that the cos of 2a is going to be 3 over 5, and we said 2a was equal to theta, and we're going to value the cos theta, so we have the value of cos theta. Cos theta is 3 over 5. Part B of this question, solve the equation. Tan b plus 150 is equal to minus root 3. Okay, so good knowledge of the unit circle rewards those in this question. So we know that the tan of 30 is equal to 1 over root 3. These are the things that jump out at you, which will remind you that the tan of 60 is equal to root 3. So based on CAST, when is tan negative? Well, tan is negative in here in the cos sector. So I draw my 60-degree angle, which is actually 300 degrees. And tan is also negative in here, so I draw my 60-degree angle in here. This angle is actually 120. So my solutions here, 120, 300, adding 360 onto both, I get 480 and 660. And I don't know, b is between 0 and 360. Let's just do 2 more, or we'll do 1 more anyway, just in case. So adding 360 on to 480 is 780, 840. So we say that b plus 150 is equal to these solutions. B plus 150 is equal to all of these. So in this case, b is going to be first one 120, b is going to be equal to 120 minus 150 minus 30. For b plus 150 is equal to 300. We're going to get b to be 150. For b plus 150 to be equal to 480. We're going to get B to be 330. For B plus 150 equal to 660, we're going to get B to be 510, which is clearly above where we're at. And this one, in fact, the first solution, unusually at leaving cert, is below and given a negative angle where it's at. So there's two solutions here. For B, B can be equal to 150, or B can be equal to 330.